Hello everyone, welcome to Harsh ID Lab. Harsh Verma this side, and we are back again with our formal structure of the book, Network Warrior. And our next topic for the day is route maps. So we have been studied or learned a few things about the route map, and I've already told you that in the upcoming video we will discuss our route maps in more detail. I have also prepared the distinction between route map and ACL, the list or the methodology that until now we used to filter the routes on the basis of permit or deny statements. So without any further delay, let's continue our session for the Network Warrior. For those who don't know or is not following the series, Network Warrior is this book. This book called the Network Warrior, Everything You Need to Know that was not on CCNA examination. This book is written by Gary Dono, and this books primarily focus on the things that we missed during our CCNA preparation. This book specifically talks about the practical applications of the context in the real world, that the challenges that we face as a network engineer. And this book does not go in depth. And despite of all of that, I will say I only share the concepts that I feel worthy of sharing. So please try to get this book at your own, study it, read it. It certainly will be helpful. Without any further delay, let's SSH into my phone on which I used to take my notes, and let's continue. So topic for the day is route map, and route map says that policy routing is the term we use when we use route map to change the information regarding where the packet is routed. For example, we can use the route map to change a TTL of a value or modify the packet in certain way that if we want to change its attribute. So in order when we are changing the attribute, so in order or the process of changing this is called the policy routing. Now, the rigorous policy routing may involve process switching, which may cause higher CPU cycles of the router. So the process here the keyword is process switching. Process switching is one of the methodology our devices or a router use in order to route packets from one interface to another. Basically, the process done by router on a packet is called process switching. It is the most simple way of switching, and it's kind of slow one. So in order to fasten the speed up the things, we use multiple different kinds of switching. And actually, I've been going through this notes that I prepared. And for the next video, our topic will be the routing and different types of switching and routing, etc. Okay. So basically, switching is the internal forwarding of the packet. We will see this in more detail in the upcoming video. So wait for the next one. Okay. Finally, the statement of route maps is called clauses. So in the ACL, we use the term, for example, the permit from this to that, permit from source to destination, and we call that as a statement. And here, that statement is called clause. So route maps uses the kinda same like syntax of ACL, but the statement here is called clauses. And finally, each clause must have name of route map and the default have a number of 10. Basically, 10 is like a tracking number, and by default they have a number of 10, and each clause must have the route name so it can be linked or chained together. Finally, match and set are two basic types of command in which match selects the packet based on criteria while set modifies the basis of criteria listed. So route map is a thing that takes an example to completely understand it. So I will try to include an example of such in this video. Okay, maybe in the last one. In a route map, match statements, the placement determines the logical behavior. Okay, so in particular, we are talking about the match statement. The placement determines the logical behavior. If multiple match criteria are on the same match line that are evaluated as logical or, for example, here's an example of a route map statement or what we say is clause match IP addresses from source A to destination B, and if the both IP addresses are mentioned on a single statement, then this statement will be approved or it will be utilized. Either the packet matches the statement IP address A or the IP address B. Finally, multiple match lines within the same route map clause are evaluated as logical AND. Logical AND means both conditions must be matched in order to proceed. For example, if the clause is like match IP address with A as an IP address and match IP address B as in IP address. So this statement will only run if both IP addresses is aligned to that packet. Okay, finally, the policy routing takes place when a packet is received on interface. Hence, the policy must be placed on the Ethernet interface. Let me read it again. Policy routing takes place received on an interface. Hence, the policy must be placed on the Ethernet interface. Okay, so basically the application, this is talking about the application. For example, in context of ACL, when we used to create the allow or deny ACL statements, we used to apply that statement to an interface. The same thing need to be done on route map as well. And if it's something related to interface, then the route map policy must be placed on the Ethernet interface. And last line for this particular note is policy routing overrides the routing table. Show IP policy command will show the applied policy on per interface basis. If policy routing is taking place, show route map will explain that policy is doing. So let me slow down a bit. Policy routing overrides the routing table. Okay, so router keeps the highest priority of the routing as per policy routing. Suppose we want to modify the address bit. For example, we want one exit interface for a particular IP address. We can use that because we can modify the attributes using the route map. And despite the route map, or sorry, despite the routing table saying that the traffic should exit the interface 00, but if we make a policy to make it exit with 01, the policy routing, basically the route map override the routing information base RIB table, and the traffic will exit with G01. Okay. And as I said, I will try to include an example of the route map. So starting with a little bit comparison from the ACL. Let's go to that. So quick comparison between route map and access list. So access list matches the packet or prefixes either on permit or deny basis. It used for simple filtering like IP, protocol, ports, or routes, etc. While the route map matches the routes and takes action, basically sets or modifies the attribute. It is way more powerful because it also requires ACL. Sometimes route maps also requires the help of ACL, access list, prefix list, metrics, tags, interfaces, and can set metrics. What metrics can we change? Next hop, tags, community, redistribution control, etc. If you also if you remember or recall that in previous video we'll talk about the route tagging, that is also done by route maps. Next is matching capability. Access list uses simple binary match, permit or deny using simple conditions, while route map may be conditional or may contain multiple conditions in a single clause. Each clause matches a statement. The first matching clause sets action and applies it. Finally, action. The access list only permit or deny using itself or referenced, while the route map can hit metric, local preference, metric type, tag, next hop, community, wait, permit deny, control, continuing evaluations, etc. So basically, route maps perform multiple jobs while access list simply limits to either permitting or denying the traffic. Next, use case. Access list has a basic filtering ability. While route maps can be complex and perform the complex redistribution policies, policy based routing, even BGP, Border Gateway Protocol, policy controls, conditional routing, redistribution, and modification. We have few examples down here, so we will see that also. Now, talking about the order of evolution, the access list is processed in a list order. It contains some words which is marked as a list, and we can insert some values in between by using that a gap sequence. For example, the first statement is statement 10, then after statement 20, and suppose if you want to add a statement in between, we can add the statement 15. While route map does the same, but using a sequence number. And for each permit and deny clause, match then set. If denied, continue to next clause. And finally, route maps often references the access list, so they are both used together, or prefix list in match statement to select a specific prefix. And I that access list or prefix list might be a next good opportunity to make a video regarding the differences in between them. Okay, so now we have a simple example in an iOS, the Cisco iOS, that access list is used to match the permit network. For example, the access list 10 permit an IP address of 10.0.0.0 with an wildcard mask of 0.255, 255, 255. Access list uses wildcard mask. The wildcard mask is basically the flipped or inverted subnet mask. But route map using that ACL to redistribute and tag. So now we are filtering the route using the access list, and now we are modifying it using the route map. How we can do that? So the clause for route map is route map with a name which is RMOSPF to EIGRP, permit 10, match IP address 10, set tag 100, router EIGRP 100, redistribute OSPF1, route map, and its name. So basically, we are modifying, we are matching its IP address, it assigning a tag of 100, then we are initiating a EIGRP process and redistribute the same in the process of EIGRP. So basically, we are redistributing an OSPF route to EIGRP. Now we have another example, and another example is about ACL to permit any IP packet from any source to any destination. And the ACL goes like access list 101 permit IP any. So basically, it's a simple plain access list that permit all of the traffic, whether it's incoming or outgoing, to any IP addresses. Now, finally, the route map to permit any IP packet from any source to any destination, simply route map with a name GAD permit 10 and my match IP address 101. So basically, it uses the access list which is named 101. And finally, another 2 cents from my end. Rule of thumb: use an access list or a prefix list to define what to match, and use a route map when you need to take action, set attributes, apply multi-step policy logic over it. And that's it for from my side. Make sure to watch the next video to not miss the routing and its different types. And thank you for watching this video. Thank you for joining. Thank you for coming in.